All right, my mighty Mavericks. Last time we discussed this concept of similarity. All right. Similarity exists as long as all of the corresponding sides are proportional and the corresponding angles are congruent. That's a lot of work to do. All right, a lot of investigations. If you remember, though, when we talked about triangles before, there were shortcuts. We discussed the shortcuts. Remember, this symbol is for congruence. The congruence shortcuts, we had side, 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 side angle, side, angle, side angle, 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 side, and the hypotenuse leg theorem. All right. We had those shortcuts that we could basically cut our work down by half. All right. The good thing is these triangles, they continue to amaze us with some shortcuts. This is the symbol for similarity. So remember, similarity is a single squiggly mark. All right. There's not 5 for us to investigate. There's only 3. All right. The 3 shortcuts for similarity, we have side, 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 side angle, side, and angle, angle. But the method in which we investigate this is obviously different because these 2 situations are different. All right, with congruence, we wanted every corresponding piece to be congruent. With similarity, the angles are the same, but this time we need to investigate whether the sides are proportional. So here would be an episode where we know all of the sides, so we could investigate whether we have the side, side, side shortcut. In order to investigate that, we need to set up all of the ratios and investigate whether these ratios are all the same. Now, you got to be careful. Make sure you're matching up the right pieces. Now, this here, it can be confusing. All right. None of these letters are in an alphabetical situation. We don't know what the corresponding sides are, or do we? If you see every side, if you know all 3, all right, the sides can be ordered in a numerical ascending order. All right, smallest side here is 2.4 in this triangle. So let's make sure that we match it up with the smallest side in the other triangle. So we want to see, does the comparison between 2.4 and 3.6, we want to compare that to the other ratios and see if we actually have proportionality. Well, the biggest side is 3.2. So again, if you're putting, if I put 2.4 over 3.6, I got to be consistent. I got to continually put the sides of this triangle on the top. Otherwise, I certainly will not have proportionality. So the longest side is 3.2. The longest side here is 4.8. And the one in the middle, 2.6, has to match up with 3.9. Just because I made ratios doesn't mean that I have proportionality. All right. So the big trick here is I want to go with one of my 2 methods that we taught before. I can either cross multiply or try and reduce those fractions. This time I'll go ahead and go with cross multiplication. 2.4 times 4.8 is 11.52. 3.6 times 3.2, look at that. If I get 11.52 again, I know these 2 ratios are proportional. Now, I haven't investigated, I haven't involved this ratio, so I got to kind of go at this again. Now, 3.2 times 3.9, man, I got something different. Is that a bad situation? No. It's okay that I get a different value than before. I need these 2 to match, and then I need the other 2 to match. So as long as 2.6 times 4.8, as long as that's 12.48, we're good to go. I got 12.48 again. That means these 2 ratios are proportional. Now, do I need to compare the last ratio with the first one? I don't, because we can due to the transitive property, If A is the same as B and B is the same as C, then I know A and C are the same. All right. But you need to verify. You need to check it out. You need to set up the ratios. You got to be consistent. You need to investigate. Turns out that these are similar. So I certainly can say, yeehaw. I need to mention that I am using this shortcut. And you might actually be asked to set up the similarity statement. So if I say triangle MBT, doesn't matter how I list the first triangle, but then I got to make sure the pieces match up in the second triangle. I know M matches up with N. And if I go over to B, that means I went along the smallest side. So I got to go to R. If I get two of them, the third one should be not so bad. Okay? So this was an example of side, side, side. Now I'm going to try and sneak in real quick. All right. This would be an example of one of the other shortcuts. So if I had 15 and 10 and I had 6 and 9, if we're looking at this situation, again, we got to play this game well. I don't have all three sides, so I'm certainly not going to go after side, side, side. But I do have two of them, and I do have a pair of vertical angles. So if I was working on a physical test, I would want to tell the person grading my test, oh, I got an angle that's congruent. Those are vertical angles, could be used in a proof. Now I'm going to set this up. If I'm going to set 6, what am I going to match up with 6 within the other triangle? Well, if 6 is smaller than 9, I need to match it up with 10. All right. Then I can match up 9 and 15. I don't know if this is equal yet. The only way to go about, not the only way, but I'm going to cross multiply. 9 times 10 is 90. 6 times 15 is 90. So understand I had two sides and the included angle. The angle has to be in between the sides. This would be an example of side angle side. Okay. And so we've investigated those first two options. Let's look at the last option. This would be a common scenario that you might see for angle angle. All right. Let's go ahead and put some letters here. A, B, C, D, E. Now here, I've told you none of the sides. So you certainly should not be thinking about side, side, side as an option. You should not be thinking about side angle side. The only possibility we hear, and doesn't mean that it's going to work, but that's my only possible option since I don't know any of the sides or have a way of investigating proportionality. So let's make sure we're aware of all of the possible congruent angles here. All right. If we have parallel lines and a transversal, please realize these two angles here, this angle D would have to be congruent. Now I can't say angle E because there's multiple angles here at point E. I got to use a three-letter system, AEB. Those triangles have to be congruent. I could easily verify that in a proof. All right. Those are what we call corresponding angles. Remember, every skill you learn along the way has got to be a tool that you keep in your belt ready to use. In case you didn't know, there's corresponding angles here as well. Now that would give us two angles, which means this is done. Just want you aware, this triangle up at the top, all right? I can actually do this one as well because realize angle A is an angle in the small triangle. Angle A is also an angle in the big triangle. And we know that angle A has got to be congruent to itself. We've seen this property before. Be ready to use it. This is our reflexive property. All right. So this is a common idea. Be ready for this situation where two triangles are sharing angle, bringing that reflexive property back into game. If we have parallel lines, be ready for corresponding or alternate interior angles. All right. Be ready to use those tools that we've investigated in the past. So again, here's an example of an angle problem. And then we had two examples of the other two situations. All right. Make sure you're verifying things each time. Don't assume that's going to get us all in trouble. All right. Good luck, everybody.